Hello, I'm Wataru, and this is Mariko from University of Tokyo. Today, we'd like to discuss tracking Mimikatz by Sysmon and Elasticsearch. First, this is my profile. Again, I'm Wataru Matsuda. I'm project researcher for computer security. I experienced CISA survey and published a report and book in Japan.
Hello, I'm Mariko Fujimoto. I'm also a project researcher of University of Tokyo, and we have been together working for vulnerability verification or log analysis. Nice to meet you.
We've been investigating how to detect attack from logs. So this is our first presentation in international conference. So I'm a little bit nervous. So we are very glad to talk about our research in public. Thank you very much. So this is our organization, Sysmon Tokyo. Sysmon Tokyo researches on internet security through collaboration with industry, academia, and government. So we mainly promote human resource education and research for cybersecurity. Here's our agenda for today. Finally, we will show you a demonstration and specific method of searching for Mimikatz activity. Background. In a targeted attack, attackers often hack Active Directory using Mimikatz. Mimikatz is a hacking tool for Windows OS. Targeted attacks are becoming more complicated, and attackers may remain for a long period of time. This figure shows simplified cyber kill chain, preparation, intrusion, lateral movement, and activity. So only 4 steps. Now, in targeted attacks, 100% intrusion prevention is not realistic. We need to consider that attackers are inside our network. So it's important to detect lateral movement and respond as soon as possible. Wait a moment. Thank you. Thank you. はい、ありがとうございます。By the way, let me talk about Active Directory. This is an overview of Active Directory. The Active Directory is a directory service developed by Microsoft. If you are a domain administrator, you can access any information and control all users and computers. These features are very convenient not only for administrators, but also for attackers. This is why attackers leverage the Active Directory. According to JP-CC, Active Directory was under attack in many targeted attacks. Attackers leverage domain administrator privilege in 15 of 16 organizations, almost all. This is a breakdown. In many cases, attackers use stolen credentials or Active Directory vulnerability. Generally speaking, attackers move laterally in the network after intrusion. First thing to do for attackers is using Mimikatz for stealing credentials, and eventually gain the domain administrator privilege. Once an attacker gains domain administrator privilege, they can control Active Directory environment completely. And of course, they can easily steal sensitive information from servers, from computers. The Mimikatz. This is a hacking tool for Windows OS. Many attackers use Mimikatz to get credential information from computers. This is one example of Mimikatz. You can see the password is password. very weak password. And update often released with enhanced features. And trademark is Kiwi. So as you can see, this is the credit information. This is just one example of Mimikatz feature. Mimikatz have several functions, such as stealing credentials, private escalation, and create forged authentication ticket, called golden ticket. In general, attackers hack computers again and again to expand infection using Mimikatz. Challenges. A lot of persons in charge of computer security are eager to detect Mimikatz. However, you cannot clearly detect Mimikatz activity with Windows event logs. Recently, some reports of Mimikatz detection using Sysmon were released. These reports said that Sysmon record DLLs that are loaded by Mimikatz. These reports also introduced a method of detection, but researchers tested specific Windows and Mimikatz versions, which may cause false detection in your environment. In our research, we analyzed DLL loaded by each Mimikatz and Windows version. And we also show you a method for more effective detection. So let me explain about Sysmon. Sysmon is a free tool you can download from Microsoft website. Sysmon monitors process and loaded DLLs and so on. Sysmon records this information as Windows event log. If we know signature DLLs loaded by Mimikatz, we might be able to detect Mimikatz activity. This is one example of Sysmon logs. Here is image. This means parent process. In this case, Mimikatz.exe. Here is image loaded. This means child process. In this case, wintrust.dll. In this case, this means Mimikatz.exe load wintrust.dll. And there are a lot of information, such as process ID, computer name, and user account names in Sysmon logs. Sysmon is a very useful tool. In previous research, these reports introduced detection method for Mimikatz activity. The formal report is written by Jake. This report introduced DLLs loaded by Mimikatz. I think this report is the first report of Sysmon for detecting Mimikatz activity. And later one is written by Robert that explained how to detect Mimikatz activity with ELK, Elasticsearch, Logstash, and Kibana. We refer to their method. In previous report focus on the detection method, but they don't test various Windows and Mimikatz versions. Previous report tested only Windows 7 and only one version of Mimikatz. So we found out DLLs are changeable depending on Windows and Mimikatz. For example, in Windows 7 environment, Mimikatz load LPK, USB10.dll, and so on. On the other hand, in Windows 10 environment, Mimikatz load DLLs different from Windows 7. There is a difference of Mimikatz loading between each Windows environment. We can say the same thing about Mimikatz. Accordingly, if you use the DLL list from the report, it can cause a false detection. For example, this DLL list can detect in Windows 7 environment because DLLs are totally matched, but in Windows 10 environment, not detected because bcrypt32.dll doesn't match. This means false negative.
Okay, from here, we will explain our proposed method for more practical use of previous research. So we mentioned that we mentioned that DLLs that are loaded by Mimikatz are different depending on environments. So we examined the difference of DLL loading with various Windows and Mimikatz versions. So as a result, we find that there are some common DLLs that are loaded regardless of environments. So for this example, these three DLLs are loaded regardless of Windows version. So by using these common DLLs as a target to be detected, false negative rate can be reduced even the environment is changed. So we examined in the combination of sorry, uh, we test we tested we examined loaded DLLs in these. Sorry. Sorry. So we examined loaded DLLs in the combination of these Windows version and these Mimikatz versions. So we tested all currently supported Windows versions. And we executed Mimikatz in these Windows versions and create common DLL list. So we called commonly loaded DLL list as common DLL list. So it is difficult to test all Mimikatz versions because updates are often released. So we selected these three Mimikatz versions. So Mimikatz 2.1.1, this was the latest version at that point. However, a recently newer version of Mimikatz is released. However, we haven't tested yet. We are sorry. And second, so Mimikatz 2.1 was released around the time when the difference in loaded DLLs was reported in this previous research. It was about a year ago. And Mimikatz 2.0 was released when targeted attacks started to increase in Japan, such as against Japan Pension Service. This was about 2 years ago. So we evaluated detection rate of our proposed method. So we checked if the Mimikatz execution is correctly detected using the common DLL list. So we conduct normal business operations like this for a few days and run Mimikatz several times during these operations and gather Sysmon logs from these test environments. So this is a detail how to evaluate the detection rate. At first, check the DLL. So this image loaded, recorded in event ID 7. And next, check if any of DLL match the common DLL list. So in this case, this DLL is included in common DLL list. And then check the process name. So this image, and that wrote all DLLs in the common DLL list. So please note that event ID 7 is recorded every single DLLs. So we should investigate all event logs regarding the process. And if there is a process that wrote all DLLs in the common DLL list, and process name is mimikatz.exe, so Mimikatz execution is correctly detected. So in this case, so process name is mimikatz.exe, so detected correctly. However, if it isn't, we consider it as false detection. From here, we will explain the result of our verification. So this is a part of a result of Mimikatz DLL loading. So this is an example of difference among Windows versions. So you can see several differences among Windows versions. For instance, this DLL is only loaded in Windows 10. On the other hand, there are some common DLL, so regardless of Windows version, so highlighted in yellows. So this is only a part of our result. So we published all results on our GitHub. So this is an example of difference among Mimikatz versions. So you can see several differences among Mimikatz versions. So relatively in short terms, so only for 2 years. So we think it can be changed in the future update of Mimikatz. So this is a list of DLLs that are commonly loaded in all tested environments. So these are Windows system DLLs. So other applications can also use these DLLs. So we can't decide whether Mimikatz is executed based on only each DLL. So it is a key point to check whether all of these DLLs are loaded. So this is a result of detection rate of our proposed method. So we tested more than 3,000 processes, including Mimikatz and legitimate programs. So we haven't seen any false detection so far. However, we didn't test all possible cases. So please note that false detection can be occur depending on environments or operations. So we will explain how to use the analysis result of our proposed method. So here is an algorithm of detection. So we propose to use common DLL list. However, if false positive occurs by using only common DLL list, we propose that at first compare with common DLL list, and second, compare with DLL list for specific Windows version. We think it is possible to improve the detection accuracy effectively by this algorithm. So in step 2, so compare the loaded DLLs with the DLLs for corresponding Windows versions. For instance, if you want to check the Windows 7 computers, so please compare with DLL list for Windows 7. So we provide DL list for each Windows version. So on our GitHub, in addition to common DL list. So please use it as a reference. So this is observation on the analyst result. At first, so more DLLs tend to be loaded in newer version of Windows and Mimikatz. And second, so even for the same Windows and Mimikatz versions, so there are differences depending on some environment factors. For instance, these are both tested in Windows 7 and use same Mimikatz versions. However, at the left, so it is initial status after installation. So no patch applied and PowerShell version is 2.0. On the other hand, the right so applies latest patches and PowerShell version is 5.0. So you can see several differences. So we think loaded DLLs can be different, so depending on various environment factors. So we suggest to maintenance the DLL list to be detected suitably. So from here, we will show you demonstration of our proposed method. So we need some tools to use our proposed method in real environment. So we created some sample tools. So there are two Java tools. At first, for creating common DLL list, and second, for detecting Mimikatz. So these tools can parse exported event logs as CSV file format. So it is difficult to parse event log itself. However, we can export event logs as text file using Windows normal function. So this is a flow of the tools. The first tool gather exported event logs from test environments and extract DLL loaded by Mimikatz and create common DLL list. The second tool compare with common DLL list with logs from computers we want to check. So we will show you a demonstration. So before using our tools, so we firstly should export our event logs as CSV file format. So this is the event viewer. So we can export this. So this is a Sysmon log. So we can export event logs like this. So save as events. And so we can specify the file format. So select CSV and save. So that's all. Very easy procedure. So let's execute the tool and detect Mimikatz. So we provide two Java tools, and we provide tools as Eclipse project files. So you can download from our GitHub and import your Eclipse. The first tool, create common DL list, can parse exported event logs and create common DL list. So these are input directory of the tools. So these are input files. For instance, so this is exported event logs from test environment. So this log contains all image loaded events, so including Mimikatz. So like this. So this tool parse event logs and extract DLLs loaded by Mimikatz. So let's execute the tool. So the tool is executed. So these are output of the tools. For instance, these are DLL list loaded in Windows 7. And this tool also can create common DLL list like this. These are DLLs that are commonly loaded in these test environment. And you can also see the all result of DLL loading, so like this format. But next, so let's detect Mimikatz using the common DLL list. So this tool, Sysmon detect, compare with common DLL list and logs. So these are input of the tools. So this is also exported event logs from computers we want to check. Also CSV file format. So let's execute the tools. This. So this tool can so this phrase is too small, but this tool can show the environment name and process ID, so that loads all DLLs in the common DLL list. So the Mimikatz can be executed on the listed process. So we should check this environment. So my demo is all. So however, it is not realistic to investigate each environment. So next, so Wataru will show you a demonstration using log centralized tools.
Okay, this tool can detect Mimikatz activity using centralized log with Elasticsearch. This slide shows overview of detection using ELK, Elasticsearch, Logstash, and Kibana. ELK can gather Windows server, ELK can gather Windows event logs through WinLogBeat. First, you have to install Sysmon and WinLogBeat into your PCs. And next, Sysmon record DLLs, and WinLogBeat send Windows event log to ELK server through Logstash. Finally, centralized logs are analyzed by Elasticsearch. I'll show you. Here is the Kibana display. You can see the overview of Windows event logs, and here is the visualize of parent process. So this is image loaded. Child process. Here is image parent process, and it shows process ID, and client name. So I think the Kibana is a very good tool for visualization, but in this study, I couldn't find the way to detect Mimikatz activity using Kibana. So in this study, I don't use Kibana. I made Mimikatz activity detection tool using Elasticsearch with Python instead of Kibana. So I'll show you. So this is a Python tool for Mimikatz detection. Sorry, the character is very small. Here is the common D error list, and around here, creating query and analyzing. This code is only 100 lines, very simple, very small tools. Okay, so let's move suspicious executable file. Here is the xxx.exe file. So you can see the QE mark. In the real environment, attacker will change the file name from mimikatz.exe to something such as svchost.exe, likely real file name. So in this demo, we changed the name xxx.exe. Let's execute this file as an administrator. Okay, this is a Mimikatz. So we can think this computer was compromised by attacker, and attacker ran Mimikatz as an administrator. Let's detect with this tool. Now, sending query. At that time, the Windows event logs are sent by WinLogBit, and this tool analyzed the Windows event logs. So, sorry, very small. This is xxx.exe, and here, process ID and time, and client name. You should start instant response if you detect Mimikatz activity. These codes are published in the GitHub. So please feel free to use this code. So that tool was the overview of that tool. The Python tool sends the JSON query, including common D error list, and Python tool receive response, including logs matched common D error list. Finally, analyzing logs and detecting Mimikatz. The reference. So, source code that we showed you a demo was published in GitHub, github.com/SysocTokyo. The test result and her Java code and my Python code are included. Please feel free to use these files. The future works. In that demo, we use log forwarding agent, WinLogBit, but sometimes it's difficult to install log forwarding agent in your environment. So we will research better way to gather the logs. So we guess the WMI is a random solution, but we need more investigation. And this is another topic. Let me explain about invoke Mimikatz. Actually, there are two choices to use Mimikatz. First is Mimikatz file, such as mimikatz.exe, called Mimikatz on disk. We tested this option, Mimikatz on disk, and I showed you the demo used Mimikatz on disk. Another is invoke Mimikatz. Invoke Mimikatz is PowerShell module. Attacker loads Mimikatz process into memory directly. So this means fileless Mimikatz. If an invoke Mimikatz was used, you can see PowerShell.exe as a parent process. So actually, I wanted to show you the demo, but this PC doesn't have internet connection environment. So I'll show you the movie. first execute the PowerShell as the administrator. So invoke Mimikatz run on PowerShells. And invoke Mimikatz is very simple, only one liner command for executing. So download Mimikatz from internet and executing. So you will see the credential information. Just a moment. This is the result. So you can see the password, there is a credential information. So this is Mimikatz. So you can detect same tools and same common DLL list. You can find, you can detect invoke Mimikatz. So now sending queries and now analyzing. Okay, so detected. So sorry, very small. This is the PowerShell.exe as a parent process. Okay. So far, we can detect invoke Mimikatz, but however, we need more information and data about invoke Mimikatz. So we will continue the research. This is under investigation. And one more thing, we introduced Sysmon, but it might cause a large amount of logs. So you can see more than 90% logs are event ID 7, Sysmon. That's too much. So we need to configure the settings of Sysmon to reduce logs. You can configure the config files and specify the DLL name. This is just an example. In this case, only ADB API 32 and crypto32.dll are recorded into event logs. This is just an example. Please note that in the real environment, please write down all DLLs in the common DLL list. This is just an example. In our test environment, we can reduce log amount reduce from 90% to 20%. Please try it. Conclusion. Early detection of Mimikatz execution is a key for quick response. As a result, we can minimize damages of attacks. Mimikatz load different DLLs depending on environment. So we suggest to common DLL list for detection. You can use our DLL list on GitHub, but if possible, we suggest to create your own DLL list in your environment, so you can detect Mimikatz more accurately using your own DLL list. That's all. Thank you for your attention. Thank you.
谢谢辅机组跟马子大。各位朋友们，什么问题要想请问两位讲者的？他们用了这个微软免费的工具那个 Sysmon 来做了一些行为上的分析啊，侦测那个 Mimikatz。有没有什么问题？请说。我们有日文翻译 ，We have a translator。我可以翻成中文啊。为什么不用 API call 的顺序来侦测，而用 DL 档？因为 DL 档感觉比较容易误判。No, I just translate this question to Chinese. Okay.
We think the API call is a procedure, so we need to find the from logs. So we select the Sysmon. That enough?
So, okay.
不行，这样不行。Sysmon cannot log API call.
Oh, we don't know the information. Thank you very much. We will investigate. Yeah.
讲者表示研究会在研究，谢谢指教。请说，可以用中文没关系。抱歉，可以大声一点吗？就是给他那个给这个。
就是后续会在研究其他一些不会被防毒软体侦测到的一些骇客工具，比如说像 Dump 或 PXEXEC 之类的工具嘛。
This tool is specified for only Mimikatz, so not other hacking tools.
还有什么问题？刚刚回答我也听不是很清楚啊。没问题，赶快，我们这边中英文各种语言都可以翻译。你说。
好有，就是我想要请问一下，就是因为通常装那个 Sysmon 嘛，那它有额外再去做其他 configuration 嘛？因为它通常在做 Sysmon 的时候，它可以设定你应该要监控哪几个 DLL 档，或是其他方式，它是用预设的，还是它只是它有针对这些像 Mimikatz 这种方式去侦测它的 DLL 档，之后直接把它写到它的 config 里面？谢谢。
The procedure was on GitHub, and so we refer. So, sorry, just a moment. The specific method for detecting Sysmon. So this report is very useful. Please refer this report and our GitHub site.
So this report describe how to set Sysmon configuration in very detailed information. So please refer this procedure.
好，最后一个问题，我们还有3分钟，有问题？好，请说。
我想问一下，它这个用 Elasticsearch 用那个 Python 做是一个实时的监控，还是之后针对收集到的所有 log 是一个事后的一个 forensic？ 它是一个 real time 的 responding。懂我的意思？
Elasticsearch can search at real time, so we will be sending logs real time. But of course, the Python tool is not real time. After several, we recommend executing logs frequently, not real time. Python tool is not real time.
好，有没有问题？我看后面站了很多人，有没有什么问题想问的？好，请说。
不好意思，就是看起来是一定要装 Sysmonitor 嘛？那如果不用 Sysmonitor，用其他的那些事件检视器的资讯的话，有没有办法判断？有没有办法，比如说判断，但是 准确度没有这么高，你们有试过这个方式吗？
I think though there are another tools instead of Sysmon, but we focused on Windows default tools or free tools. So in this study, we pick up the Sysmon.
好，
So I think some security products can monitor the execution of process and centralize analysis. But yeah, we focus on Windows normal function and open source.
好，时间差不多了。summary 一下哦。其实他们做法就是他们在 Windows 上面装 Sysmon， 然后产生这个 event log 7 ，event log 7就是载入第二档的事件，把即时载入的事件透过 win log bit 传到 Elasticsearch， 然后在 Elasticsearch 做了一些研究跟搜寻，然后我们找到了一些第二的 sequence 可以侦测 Mimikatz， 看吧，只要30秒就可以讲完这个套文。好，那个我们掌声谢谢福吉子跟马吉达，谢谢。